Well, I guess we can begin. Welcome to this talk, Streams in the Wild. Thank you for coming. I hope you'll enjoy your next 45 minutes in this room. What I would like to talk to you about today is, of course, about the Stream API introduced in Java 8, and especially to show you advanced patterns with the Stream API, basically based on the Spliterator API, which is an API from inside the Stream API. This will be mostly a live coding session. I hope you all like live coding. Yeah? Do you prefer slides? Bullet points? Plenty of bullet points? Many, many bullet points? I've got something for you for that, if you're in that. This work is mostly based on a work I've published on GitHub, sorry, a few months, if not more, a little more than a year ago, an API called Streams which is basically an API that extends what we're going to show, what I'm going to show you in the minutes to come. My name is José. I live in the Paris area. Here are some links with some of my works you can find on the internet, including YouTube talks. I'm also a proud member of the Paris Java user group. In case you have questions, just raise your hand, shout, make some noise so that I can hear and see you and take your question. Do not hesitate to interrupt. Do not wait for the end of the talk if you have questions. And if you have questions afterwards, you can use this hashtag. I'm always monitoring it. So if you have, it's a good way to interact offline after the conference. And that's it for the slides. Now, I know that some of you probably like bullet points. I do not want to create any kind of frustration in the audience. So I gathered a bunch of bullet points here for you guys. And that's it. Any Oracle open world only people in the room? I shouldn't be saying that. Imagine the answer is true. What I'm looking at, yes, this. I need to switch this, right, and switch to here. This is an IDE. Can you see it? This is our favorite tool. Is the font big enough for everyone? Yeah? Could it be bigger? How can I do that? Presenter mode, maybe. Where is it? Here. Presentation mode. Is it bigger? Not really. Yeah? Is it okay for everybody? Okay, fine. So what do we have here? We have a basic list of strings, Java 8 style. We could have used the wonderful factory method from the list interface, but this is still Java 8 code, so it's not. You all know that to create a string on this, we need to call the stream method on it, and from that, we can just call, for instance, for each to print out the content of that stream. Okay, let us run this code. Great. It does what we expect it to do. Where does this stream method comes from? It comes from the default method from the collection interface. That, in fact, does two things. Create a spliterator here by calling another default method and passing this spliterator to a StreamFactory method of the stream support class, which can create stream. And what does this stream support class do? It does, once again, several things. It creates an instance of this reference pipeline.add class, which is in fact the implementation of the stream interface itself, and pass the spliterator object we just created to this implementation. If I'm showing you this code, it's just to show you that, in fact, a stream object as an implementation, as a runtime object, is in fact created on two objects, or at least two objects. First, a reference pipeline object, which is in fact where all the complex algorithms, the map, filter, reduce, collect stuff lives. And another object, a spliterator object, that is passed as a parameter, as a collaborator to this implementation, and that is in fact meant to be overridden. If I go back to this spliterator method, I'm in stream support. Hey, sorry guys, I'm in trouble with this presenter mode. Okay, let us, oops, it's not even the right one. No, not this one. This one, yeah. If I go back to this Spliterator object here and see what it does, it is indeed a default method from the collection framework, but that is overridden in nearly all the classes of the collection framework. Here's the override of this Spliterator method from the ArrayList class, for instance. It returns a Spliterator that is particular to this ArrayList object. And in fact, what does this Spliterator object does? It does the same kind of thing as the iterator does to the collection implementations. You know that we have ArrayList and an iterator for ArrayList. The same for hashset and an iterator for hashset. The Stream API works kind of the same. We have the implementation where all the complexity is, and we don't want to look into that, and an object that in fact holds the logic to access the data. And this Spliterator object is a little more complex than the iterator object, but it's still fairly easy to implement yourself, either to connect your streams to particular sources, non-standard sources of data you may have in your applications, or to create streams over other streams. Once we've seen that, we can begin to play with it. For instance, saying, okay, I'm going to take this code, take the iterator of this object, put this iterator in a variable, and just create another stream by calling this stream support dot stream iterator and pass false. The second parameter is a Boolean. This Boolean is true if you want this stream to be parallel, and false if you do not want this stream to be parallel. Here I'm not going into this kind of things, so I'm just going to keep this as a false value. So this is a stream of string. Why isn't it happy with it? And from that, I just want to catch that. What problem do I have here? I really don't see. String. Yes, sir. Oh my God. Thank you. This is a Spliterator I need, not the iterator. And I'm going to call that Spliterator. Spliterator. All right. Let us run this code, and in fact, it runs in the exact same way as the previous one. Okay, so how can we create other Spliterators starting from this Spliterator created on that stream? Let us do that. I'm going to first create a very simple Spliterator that in fact does nothing. And it will be a good occasion just to visit the interface we need to implement and see how the methods we need to implement work. So I'm going to create a no operation Spliterator of string. No operation Spliterator. Let us create this class real quick. I want to create it in that package. Great. It implements Spliterator of T. Right? What do we have here? We have, in fact, a collection of methods to implement, which are abstract methods. There are 4 of them. And 4 other methods that are default methods that we do not need to implement in a first step. All right? We will look into that more precisely because there is a trap in that. Okay, so this is our basic implementation. I'm just going to do a little further, go a little further here because this no Spliterator is in fact going to be created on the Spliterator of the underlying stream. So I'm going to create this constructor. Great, this is a Spliterator of T indeed. And I want to create that field. And this idea is really great in implementing that. Right. So now I have this no operation Spliterator created on another Spliterator itself created on an incoming stream or on an upstream. Right. What do I have to implement for that? I have 4 abstract methods that I need to implement. Of course, if I do not do that, it will not work. try advance, try split, estimate size, and characteristics. Now, you may think that those methods have kind of bizarre names. Try split, estimate size. On collection, I have a size method, but I do not have an estimate size method. And this is, in fact, quite normal, and it comes from the way the streams work. When you create a stream on a source of object, you do not necessarily know how many objects you are going to process through that stream. You do not know that. When you create a collection on an array list, for instance, or set of objects, you know exactly how many objects you have in this array list. But this is not the case for a stream. If you create a stream on an array list, okay, you know the number of objects you are going to consume. But if you create a stream, for instance, on a text file, and there's a method for that on buffered reader class, which is called lines, this method returns a stream on the lines of this text file. Even if you know that there are 2 megabytes of content in this text file, you do not know in advance how many lines there are in it. There may be 1 line or 1,000,000 lines or 10 lines. You need to analyze the text file for that. So it's really a method, estimate size, that does that, an estimation of the size of the stream. In some cases, this estimation may be accurate. In some other cases, it may be not accurate. For the moment, what I'm going to do is just wire this method on the underlying spliterator. So this estimate size will just return the same result as the estimate size of the spliterator I am created on. This try-split method will be called if I want to go parallel. Going parallel means I need to split my stream in 2 parts, give the first part to a given core of my CPU and the second part to another core of my CPU and process stuff in parallel. If I do not want to go parallel, or if I am sure I will not go parallel, I can return null with this try-split method. Characteristics, for the moment I will not go into details in this method. We'll do that in a minute. For the moment I will just continue to return the characteristics of the underlying stream. And now there is this try advance method. This is really where I need to write my code if I want to do stuff, non-trivial stuff. Let us state it like that. This try advance method can be seen as the equivalent of the next method of the iterator object, but it works differently. First, it returns a Boolean, right? And this Boolean, of course, can be true or false, as many Booleans. If it's false, it means that I do not have any more objects to produce with this spliterator. And if it returns true, it means that I should, the implementation should keep calling this try advance method because more objects are coming. Okay? And now it takes also a consumer as a parameter, action. We need to understand that this try advance method is going to be called by the reference pipeline object, provided the spliterator is provided to that object, so it's going to be called by the implementation. And the implementation will check if there are more objects to be consumed, and if they are, will expect those objects to come at some point, but not necessarily at the moment at which this try advance method is called. We're going to see examples of that later. So this consumer is provided by this reference pipeline object, and I should call the accept method of this consumer with the objects I want to consume. Okay? So somehow, I am on a spliterator created on another spliterator. So if I want to know what objects are going to be consumed by the stream I am in, I need to call the underlying spliterator. So in fact, also call this spliterator dot try advance method. And do the same, that is, provide a consumer to this try advance method to get the object produced by the underlying spliterator. So let us provide a consumer. This is a consumer, doesn't do much. This consumer will be called by the underlying spliterator, the one I am created on, and this object here will have to be passed to the reference pipeline that is calling me. So what I need to do is just call action.accept of t. Right? Here I'm not doing anything. I'm just calling the underlying spliterator, hey, do you have objects for me? If so, just call the consumer I'm giving you. And if my consumer is called, then I take the object and call the other consumer given to me with that object. And this is the way an object is transmitted from a spliterator to a stream, by calling this consumer. Now, this try and vamp method is going to return a Boolean. I'm going to call it as more. This Boolean will be true if there are more objects to consume, and false if it's not the case. So since this spliterator is not doing anything, I can just return this as more object just to complete the process. And now if I check my calling code, this spliterator, I can just provide it here. So this stream is now created on my no operation spliterator, and I should not observe any kind of difference since my no op spliterator is not doing anything. So let us run this code, and indeed, I have the exact same behavior as previously. My no op spliterator is not doing anything. But then I can go one step further by creating, for instance, a spliterator that is going to block some objects, not transmitting all of them. Suppose we create a filtering spliterator of string. Let us call it filtering spliterator. I'm going to create it just as the previous one in this package. I'm going to implement spliterator of t. And basically, I will just have the same code as the no operation spliterator. So I'm just going to copy paste all this. Yes, this is a consumer. All right. I'm going to, by the way, also copy this, the constructor. This is the constructor of the filtering spliterator. And I'm going also to pass a predicate as a parameter, predicate of t, that I'm going to call filter. And just do that, this filter equals filter, filter, create the field, just like that. And now, in my try advanced method, what I want to do is say, all right, I see objects coming up from my underlying spliterator. As long as I can see object, I will continue to return true because it means that I can produce more objects. But I do not want to transmit the object that do not pass this filter here. So if filter.test of t is true, then I transmit the object. And if it is false, I do not transmit the object. Right? Let us see what it does. So this filtering spliterator is created, let's see, on the no operation spliterator. It needs a predicate of string. Let us select only the strings with length 3 and run the code. Okay, so I need to pass my stream here on this filtering, of course, spliterator, or else. And you see that this time, only the objects with 3 characters have been transmitted to the downstream created on the filtering spliterator. So this, you see that if I show this example to you, it's just to show you that it's not because I'm returning true that I need to transmit an object to the downstream spliterator, right? If I return true, it just means that I have more objects to send, but maybe not now, maybe later. And if you examine the Stream API, there are at least 2 examples that works like that. The first one, the most obvious one, is the sorted example. To sort a set of objects, you need to see them all. You cannot begin to produce objects until you have seen all the objects produced by that stream. So this accept method will keep answering true without producing anything. And once the upstream is completely consumed, then the sorting will occur, and then the transmission of the objects will be done. And the second example, the distinct also. Distinct works with an internal index. If an object is seen, do I have already seen this object? If not, then I transmit it. If I did, then I'd block it. It's kind of adaptive filtering, as in this case. So in fact, this is a very classical way of using this spliterator stuff. A spliterator can also be used to modify the object transmitted. Let us create a mapping spliterator. Mapping spliterator of string. I'm going to keep it simple, so I'm going to create a class, once again in a spliterator package. I'm going to, copy paste all this, in fact. All right, not this one. Great. So this is a mapping spliterator, and in fact, the second element is not going to be a predicate, but let's say a unary operator, which I'm going to call a mapper. And this mapper will be a mapper, so I need to change this one again. So now what I'm going to do is in fact, remap this T object using this mapper. This is my mapper, using this mapper. So I'm just going to call mapper.apply of T. That is, I am changing the nature of this object. Here I'm not changing the type, but I could change the type as well, and transmit this transform object to my downstream. So let us work that on an example. I'm going to take my filtering spliterator, pass, for instance, strings to uppercase, like that. This is my mapping spliterator. And then on this spliterator, I create a stream and see what it gives. And you see that both the filtering and the mapping have been applied. That is, I've just chained my different spliterator in a whole chain. Okay? But what I could do also, so here, what I have done, I have blocked object, I have transform object, but I can also create more object in the downstream spliterator than I had in the upstream spliterator. Let us create a fourth one, a repeating spliterator of string. Repeating spliterator. Let us create this class here. Going to copy paste this code to make things quicker. I implement spliterator. This is a repeating spliterator, and I can, for instance, pass an integer as a parameter. This repeat, equals repeat. Yeah. Create the field. Thank you. And then each time I get an object, what I want to do is repeat that object the number of times I'm passed it. So if repeat is equal to 3, for instance, I want to repeat the object, the incoming object, 3 times. So I can do it, I guess, like that. In stream.range from 0 to n. Sorry, repeat. And then for each index, action accept. Yes, that should do the trick, right? If I go back to this stuff, yes, I need to instantiate it. New repeating spliterator on the filtering spliterator by a factor of 2. Create the stream on it, run the code, and you see this time, what did I, yes, I didn't take the mapping spliterator. Let us take the mapping spliterator. Okay, so here you see that every element has been repeated twice. See? So you really, yes, question? Yeah. You mean in try advance? Yeah. Yeah, that's okay. That's okay. This is what it's not. Dr. Deprecated does not agree with that. Why not? So you're just allowed to call the consumer once? Yeah. Are you sure of that? Yeah. So this is a bug. We need to discuss about that more. I really wonder how your sorted method can work if you do not allow this kind of thing. So you're not allowed to do that? If you change the behavior in 10, that is in 2110, 10.3. All right. Well, it works, right? It works pretty well. Yes, we're not going parallel there, clearly. There is another point I would like to raise, is that this Spliterator estimate size here. Because obviously I'm multiplying the size of the Spliterator by the repeat factor. This is a long, and the estimate size might be long.max value in some cases. So if I just return repeat time this Spliterator repeat here, time this Spliterator estimate size here, I might go into trouble because this long might become negative if this estimate size is itself long.max value. So I'm not going to write this. I'm going to keep it. This is just an estimation anyway. So I'm just going to keep it like that. I just told you a few minutes ago that it was that implementing those 4 methods was enough to implement a Spliterator. In fact, it's not exactly the case. Suppose this Spliterator here becomes sorted. Right? Could do that. Run this code. And here I will get an illegal state exception coming from the getComparator method of the Spliterator interface. And if I check that, indeed the default method of the Spliterator interface throws this illegal state exception. Now, this getComparator method is called by the reference pipeline object only in the case of a sorted stream. So I can do 2 things here. Either I say, all right, this stream is not sorted, or either I provide a comparator from that stream. Note that here I sorted my stream explicitly, but suppose I have a method that takes a collection, any collection, and I call stream on that collection. That collection could also be, for instance, the tree set. Let us do that real quick. Tree set of string. Created on this, on this array list, of strings, pass this tree set here. And now, since this tree set is a sorted set, in fact, the stream produced is automatically sorted itself, and I have the exact same bug, illegal state exception, right? So here, what can I do? I'm going to my no-op Spliterator here. And if the underlying stream of this no-op Spliterator is itself sorted, it's quite normal to have a sorted Spliterator. So what I need to do is provide a comparator, let me override this getComparator method by providing this Spliterator getComparator method object here. And I will have to do the same, in fact, for all my comparator. Spliterator, let me copy-paste this. Spliterator, sorry, the filtering Spliterator quite obviously will not change the sorted nature of the stream, so I can do the same. Provide also a comparator here. The mapping Spliterator, since it can change the nature of the object, probably change a string into an integer or a person into the name of that person, it will most probably change the sorted nature of that stream. So this time, what I should say for this Spliterator is that the produced stream is not sorted in any case. And to do that, I need to touch this characteristics method here. In fact, this characteristics object is a word, a field of bits, and each bit of this word has a meaning. There is one that is the sorted bit. So if I want to say that these characteristics are not sorted anymore, I need to add the logical AND with it to set the sorted bit to 0. And this is the right way of doing it. The repeating Spliterator will probably not change the sorted nature of this stream, and I think that's it. So if I run this code again, now I have fixed all my streams. Either it's non-sorted, either it's sorted, and it can provide a comparator. So now I do not have the bug anymore. But I still have another bug in this code, beside the fact that I'm calling except twice. I really think I can. Which is the following. When I'm closing a stream, in fact, what can I do here? Let me just comment this code for the moment, like that. We'll come back to it later. And just produce the stream here, and I'm going to print out the result of that stream. System.out println. So if I run this code, it will print out the result. We all know that. But what I can do is set a callback on the close method, on the close call of that stream. Sorry. Let me put this in a variable. Right. Call stream on close, provide a runnable, for instance, system out closing, okay, and close explicitly and call the close method on that stream. If I run this code, then I will have all the content of the stream displayed here, and the closing method, the closing message appearing, since this callback has been called here. Now, if I keep this callback here, so now let me get rid of this code and uncomment that. All right. So here, I'm going to fall back to this stream here, call a stream2 there and a stream2 there. If I close my stream2 here, I set up a callback. Did I set up a callback? Yes, the callback is set up here. This tree set is not used anymore. And I'm just creating this Spliterator on this stream here and calling the close method of the stream I have built on this one. But if I run this code, in fact, the callback of the first stream is not called anymore, and it should be, since it's a callback, and all the streams should call their close method themselves. So every time I am creating a stream like that on a Spliterator, what I should be doing really is stream2, call the onClose, and call the stream close method of the stream my Spliterator have been created on. This Spliterator is created on this stream. then all the other spliterators are created on this one, right? So this is the stream that I need to the callback has been defined on this stream, and closing that stream created on the other one should also call the callback of this one. So now if I run my code, I have the closing method that is properly called. So in fact, when implementing a spliterator, there is the technical part implementing the for abstract method. That's okay, we saw that. But I also need to be sure that this onClose method, the onClose method, well, the closing callback is properly called when closing the new stream I'm creating on this spliterator. And I also need to make sure that I am properly handling the sorted stream that may raise exception if I do not handle them properly. So those are the two main traps in handling those streams, in fact. Questions? Yeah? Yes, sometimes you can open streams on I/O resources, which is the case for the buffered reader, for instance. So calling the close method on the stream should be closing also your I/O resource that you've been using. In fact, the stream extends auto-closable, so you can use the stream in a try with resource API. When you're just calling streams on ArrayList and you don't call the close method yourself, it will not be very, very harmful. But if you're using I/O resources, then you should definitely do that. Other questions? Yeah? Does the spliterator needs to be thread safe? It really depends on whether you are using it in parallel or not. If you're using it in parallel, the API will call this try-split method, and you should be returning another spliterator on a portion of that stream. So in itself, it depends if you have a shared state in it or not. But in itself, all the methods do not need to be synchronized and should not be synchronized by default. All right, I think that we are kind of running out of time. So I just added a few slides as a reference. The different meaning of the different bits of this characteristics word we just saw during the live coding part of the stuff. They are basically self-explanatory. Maybe sized mean that you're opening a spliterator on a structure that knows the amount of element it is going to create. Think of an array list, for instance, or hash set. And subsized, which is the other one that is maybe non-trivial, means that if you split the source of your stream, if you go parallel, then the splitting will also produce elements, well, substreams that are sized. If you split an array list in two, you can count the number of elements in each part of the array list. If you split an hash set in two by cutting the underlying array you have in an hash set or in an hash map in two, you cannot foresee how many elements there are in the right part and in the left part of this array. So the subsize for hash set, for instance, is false, whereas it's true for array list. And I also give you a hint at the StreamUtil API that you can find on GitHub. There are many more sophisticated operation than the mapping, filtering, no-op, which was really the easy one, available, like grouping, rolling, zipping. There are, I think, 20 or 19 different operators on it. And you have also an operator which does a collection on a shifting window, which is extremely useful when you have a huge stream of elements and you want to compute an average, for instance, on the shifting window. An average is just a special case of a collection, so you can do that. You can also, I also put an efficient algorithm to extract the n maxes of a given stream, which is useful in many cases. So this is the link to the Stream API. Conclusion, yes, if you want to connect your stream algorithm on your own sources of data, well, you can do that by fiddling with the Spliterator API. It's not that easy, it's a little tricky, but it's very powerful and It will really it really allows you to leverage all the powerful algorithms that are behind the Stream API, which is really great. And I also provided the link with my GitHub account. And with that, I think we are done. Thank you for your attention. I don't know, we still have a few minutes for questions if you have any. Yeah, please. I don't know if any threshold really. It really depends on what you need to do. So I never came across any kind of problem with this stuff, and I really had to manage large amount of data. Well, not big data, size terabytes of data, but in memory large sets of data, and I could do that fairly easily. Going parallel is always more complexity. And I would not recommend going parallel if you're not really sure about what you're doing. Stay in a non-parallel world as long as you can, because going parallel might, in fact, decrease your performance instead of increasing them. Be extremely careful with that. Any other questions? Okay, so thank you. I'll make the slides available on my SlideShare account very soon, so you can check that. And I will tweet about that. Thank you.